Okay, going back to the traveling salesman problem, whew, there's a major issue that I've thought come across. I've looked at a bunch of videos. Again, for anybody who's just now viewing, I'm doing these videos not for the sake of building an audience. I'd love to build an audience. I'd love to try to find it as the best way to be educational, best way to be entertaining as possible. But I need to be able to learn how to program it. And I feel like if I'm able to communicate with another person, communicate to another thing, communicate as though there was another person here, then I'm able to learn more and actually vent any frustrations that I have. One of the struggles that I have, and even on the right hand side with the suggestion boxes, there was I closed out one of the videos where it had mathematical super genius. Well, that makes me feel good. There's some people down below right here, even at the first one, Derek Hess, Hess. Again, phenomenal that you are a software engineer. But one of the things is, as a software engineer, I enjoy watching these videos. I find them relaxing. You are good at teaching. Keep up the good work. I don't get it. I don't understand. Because in his one video, coding challenge number 35.1, traveling salesperson, we can go through. He's just showing, giving a small definition of what you could possibly even do with the algorithm. He goes here, starts creating a simple model. He goes, creates possibilities. Possibilities, and then he immediately does one thing that I don't get. He starts coding. How the flip do you do that? Well, I have to go back and start doing the basics before I can even do the traveling salesman problem, and I'm not interested in doing that. Or if I'm again, and that's one of the biggest issues. Well, you have to go and learn the basics. It's yeah, okay. Intellectually, I knew that I was in the wrong, but saying it that way, wow, it was dumb and stupid. Wow, that's gonna be embarrassing when I upload it. I have to learn the basics. It's each individual one I understand. It's just how it all comes together. And again, it's probably because I got overwhelmed, and then when I view something in an overwhelmed state, then I'll become overwhelmed, associating that thing to being overwhelmed. So that's not fun. So what if I just learn how to use processing? That'd probably be something good to do. So let me go ahead and do that. Let me go to the Coding Trains content. Learn how to processing. Processing tutorial. Let's put that on mute. This is what, from 4 years ago? Fantastic. Okay, so I'm going to go ahead and download processing. I think I already have it downloaded. Processing. No, I don't. So I'm going to processing. .org. Oh, I spelled it wrong too. No, I didn't. Download processing. Windows 64. It's behind my microphone. Open. Okay. Extracting. I should pause, but I'm gonna let this ride out. It's probably a bad idea to do that if I'm trying to make an entertaining video whatsoever. So I'm gonna go to downloads. Okay, cut. Okay. I am now with him. Okay.
class you're taking. You might be a teacher of some. The other thing, those they will all be available for you to or you could just I have a camera turning off problem.
Oh, okay.
Hopefully it's going to be fine. That's the end of this builder's where you go pause, go and get it and pull it out. You'll be very happy you have graph paper. But when you had a Cartesian coordinate system, you had something called the x-axis. I'm awkwardly going to walk over here. And you had something called the y-axis.
Yes.
2, 3, 5, 4. Meaning it's x equals 5, right? With this point over here, the center here being the origin.
Now, if I remember correctly, the origin is at actually the top left-hand corner of the graph, not the bottom left-hand corner. So I'm just going to go ahead and graph that. Grabbing my trusty ruler. Process it. One, two, three, 4, 5. 1, 2, 3, 4, 5.
Zero, 0, right? And this is 5, 4, and y, excuse me, 1, 2, 3, 4, right? This should feel somewhat intuitive, somewhat or familiar to you, right? This is this idea. You have this coordinate system, and we can locate spots on the coordinate system by their numeric horizontal value x, by their numeric vertical value y. We're going to do the same exact thing in computer graphics, only the coordinate system is going to be slightly different. You know, one thing I should mention is, what is this point here? This point is 1, -3, right? This is positive 1, 2, 3, 4, negative points down. -1, -2, -3. And here's -1, -2, -3 along the x-axis. So we have this idea of this coordinate system with 0, 0 in the center, positive x going to the right, positive y going up. Now, in computer graphics, we have something similar to this, but flipped with 0, 0 in a different place, right? A computer graphics window, right? Here's a window. This is actually processing, but you can see we say, hey, that's the top left of this window, which is this big rectangle on the screen. The top left of any computer graphics window is the origin, 0, 0.
Yeah.
And this is the x-axis going this way, and this is the y-axis going this way. But we should note something. What is this point? This is the point 5, 4, right? This was 5, 4 in this coordinate system. This is 5, 4, 1, 2.
Computer desk is a mess. It's probably very clean to compare to most other people, but I have a very specific way of doing things. Gotcha. Okay. Saved a lot of room.
2, 3, 4, 5, 1, 2, 3, 4 in this word system. Y is positive pointing down, x is positive pointing to the right. What's going on? I don't know. I feel unease with this, but I don't know if this makes you uncomfortable or it's just like, oh my god, you're still talking about where the point 5, 4 is. But what we should note here is it doesn't make sense to have negative pixels, right? So all of the pixels within our window are positive numbers. There's no such thing as a negative pixel. Now, of course, all of this is going to change as we look at more advanced environments. There are certainly ways when we get into 3D or 0, 0, you want to consider it at the center. There are all sorts of reasons why you might consider negative numbers versus positive numbers. But we're starting at a very simple, nice, friendly, happy-go-lucky place where we just have 0, 0 in the top left, positive x to the right, positive y going down. Now, you might be wondering, boy, you took a very long time to explain that, and I'm not sure why I did, but hopefully that was helpful. But the reason why we really need to be comfortable with this is because as we start to write instructions to draw to the screen, the way we're going to say, hey, put a rectangle here at this xy location, with this width in pixels, with this height in pixels, draw a line from this xy to this xy location. So this idea of being comfortable with an x-axis, a y-axis, and the kind of scale of pixels is important to realize. Now, let's take this, I have an eraser somewhere, let's take this a few steps further. Now that we're comfortable with our coordinate system, let's start to understand how we might write an instruction, right? We want to draw to the screen. How might we write an instruction to draw to the screen? So let's start with, I'm going to start with something a little different than I expected. It's going to be shocking to you. I'm going to start with a line instead of a rectangle. Rectangle's off in the first example, but let's start with a line. So let's say here's our window. And the other thing about a window, we need to define, any window we need to define a width and a height. So let's say, I think most of the processing examples tend to start with a width of 640 pixels and a height of 360 pixels. This is drawn relatively to scale. So that's another thing you want to realize. If this is 0, 0 in the top left, what is this pixel in the middle? It would be halfway to 640, which we could do that math in our head, 320. Halfway
And just to make certain that I can do it, if it was 640 by 360, then half of 360 would be what, 130. No. Whoa. What am I talking about? 180. 360. Half of that is 360 degree circle. Half of that is 180. So.
Okay, right down with 360 at the bottom, become a 180. Right. So this is what we need to start getting used to this idea of scale. Right. We're not thinking of, well, it's 2 meters to the wall or 3 feet this way. We're always going to be thinking in pixels. And generally, what are we talking about? Something that's full screen, which is like 1920 by 1080, or is it a small window, 200 by 200? It really depends. If we're making a print installation, a little like game for the web. What type of scale? But we'll work in generally in this scale. Okay. So let's just say that what we.
So as an example, we do the exact same thing, drawing out. Actually, I don't even need to use this. Might be good practice to use paint or something, or I can explain it as though I was explaining to another person. So paint. So what he's describing is that, let's get this rectangle from here to here. Let's just say that this was 640. Let's just say this is 1920. This is, there we go. And this is 720. Okay, for whatever reason. And if the origin starts up here, and this is actually 0, 0. Then I want to make certain that if I wanted to go halfway, let's just say this is half, and this is half, that's going to bother me if it's not. There we go. Okay, so roughly speaking, if I was trying to figure out whatever the point was right here, then it would be this is X, this is Y. Okay. So we have an x-axis and y-axis. I wouldn't even put it there. I would put it right here and make it transparent so I can go behind. Make this go above it. Okay. So it would be 1920 divided by 2. You have it 960. So this would be point. Even put this at the bottom. 960. $360. Okay. So that's what we would get if I just did it whatever we just did there.
What we want to do is we decided we could design a little picture by making a bunch
practicing
of
it myself.
maybe the lines are like this. We're going to make a little face.
Because I would normally just do this on paper,
Right.
but
So we
this
can
is so
imagine
much
that, what if we
quicker.
draw all
Having
these lines
somebody
on
else
screen?
here to explain it to, it helps. Also, that looks like a frowny face.
We could create this.
See the 2 eyes, the nose, if that was a smiley, those are the eyebrows.
Of this very serene face. So we need to understand what does it mean to write an instruction to draw a line on the screen. And let's actually just even do, let's just do this. I'm going to arbitrarily make something up. Right? And I'm drawing little circles here to indicate the beginning and end of the line. So I don't have anyone to talk to here.
Okay, so let's do that exact same activity. What if I wanted to figure out what a line was? from one place to another. I'll make a few examples so I can try to see if I can fit them all on here. I'll use the smallest possible. Oh, no. There we go. There we go. Smallest possible line. And just pick from here to here. Yeah, let's go with something thicker right there. Excuse me. So this, let's just say that's, I don't know. 1, 2, 3, 4, 5, 6, roughly a sixth. So 1/12 of 1920 divided by 12, you get 160. This 1 point. Oh. This 1 point would be first 160, and then let's just say this 1 point is 1, 2, 3, 4, roughly about an eighth of 720. So again, 160, 720 divided by 8 is 90. So 160, 90. Whoa, I was wrong. What am I doing? What am I doing? Oh, that is so silly of me. So let's just say that's 1, 2, 3, 4. 720 divided by, no, times 5 divided by 8. I didn't do it. Okay, so 5 divided by 8. No, 5 divided by 8 times 720. So 450, roughly. Yeah. Let's go with 450. And the other one was 160. So 450 and 160. Okay. Now, this line is 60 for y, but I need to know what it is for x. So this is roughly 1, 2, 3, 4.5. So we'll go with 9 total. So, picking this up, yeah, it's roughly half 3. Let's go with 3.5. 3.5, 3.5 divided by 9. No, that's not 2.5. 3.5 divided by 9. You get that times 1920. It's about 746. So 60. Whoa, I was wrong. I might have to double check. Again, I'm really glad that I'm doing this. 746 to that. So it could be even put over here in my notes. My notes. 747. Amazing plane, by the way. For x. And then for y, we're going to have roughly 1, 2, 3, 4, 8. So 7 out of 8. Roughly. 7 divided by 8 times 720. Because the origin is at the top left-hand corner, and I think I did one of the values of over here with the origin at the bottom left-hand corner. That was my fault. So let's go with 630. Okay. 630. So our measurement for this is roughly 747, 630. Okay. Now, I want to double check this one. 450. That doesn't even sound right. That does not sound right at all. Okay, so if that was, let's just say, half for the heck of it. Oh, I think I know what I did for that one. Okay, let's try it again. 1-ish. 2, 3, 4, 5, 6, 7. Let's go with 7. I don't know, it's not an exact measurement. But 7, 14. And it's 1 out of 14. Gotcha. So 1 divided by 14 times 1920, you get 137, not 450. Wow. Okay. Pulling that calculator back up. 137 is the x. 137. It makes certain what the y was. It is 1, 2, 3, 4. I could go with 4. 4 would probably be an easier number to work with. But it's 5/8. So 5/8 from the origin. So let's go with 5 divided by 8 times 720. 450. Oh, so I had the two mixed up. Roughly. Okay. Yeah, that was my fault. Glad I put that in order. So let's do this again. It is 137-ish and 630-ish, roughly. Now, saving. No. Okay.
But you're kind of, if you're watching this still somehow, you're thinking along with me. What do we need to define how to draw a line? What we're looking for is how to write the instructions to draw a line. We're going to, once we figure that out, we're going to maybe understand how to write the instructions to draw a rectangle, to draw a circle, to draw a curve, to draw a polygon, all sorts of elaborate shapes and designs that we might want to make. But with a line, you might say, hey, a line is a bunch of pixels between point A and point B. Right? We call this point A, we call this point B. What do we need to define each one of those points? And xy. We might say this is like x1, y1, and this is x2, comma y2, right? So to draw a line, we might say, in English, we might say draw a line between. And here we can say, let's make up some numbers here. Maybe this is about 124. Maybe this is about pixel 100, and this is about pixel 50. Draw a line between 100, comma 50, to, and maybe this is like pixel 600, and this is pixel like 250. I'm kind of making this up. To 600, comma 250. Right? This is how we would write that in English. Draw a line between 100, comma 50 to 600, comma 250. We draw that line.
So I don't remember what the comment section would be for this. Processing comment section. Comments. Okay, it's just, okay, good. So it's that. Yeah, there we go. So, draw a line. Create canvas. 1920 x 720. Then another one is I want to draw a line of pulling this back up. Uh, 137, 630 by 7, 47, 630. Cool.
How do we write this in code? We don't know. This is where learning to program comes in. One of the things we have to learn is syntax. So while we kind of all have a generic understanding of the syntax of the English language or whatever language you might speak in, you're not familiar with the syntax of processing. So I'll show you what it is. This is the syntax. Line 100, comma 50, comma 600, comma 250.
So whatever the canvas is, the text would be Java, P5, Python. I don't know which one he's actually drawing it in, either Java, P5.js, or Python, or even a different one. line for whatever his is, syntax would be 100. For myself, I would do 137, 630, 747, 630. But I gotta make certain that it's XY, XY, X1, Y1, X2, Y2. 150, 600, 250, yes.
So here you go. This is our first line of code that we are ever writing in our entire lives for dramatic effect. We're saying line, parentheses, a number, comma, another number, comma, another number, comma, another number, parentheses, and semicolon. And in fact, this is where we begin. Everything that we're going to write.
I think it's the exact same way of how you write a rectangle or a square. It's RECT and then the exact same lines, and instead of having it's the top left-hand corner of the rectangle and the bottom right-hand corner of the rectangle.
Just in this sort of first beginning set of videos, I'm forgetting that the camera's there, hello, has this format. It has what we're going to say is a function name. Can you see that? Yes. Followed by a parentheses, followed by some set of arguments. We're going to call these arguments, which are values separated by commas, ending with a parentheses and ending with a semicolon. What does this mean exactly? You can think of
What?
and here we can say, let's make up some numbers here. Maybe this is this as a command for now. Truly, it's a function or a method or a procedure. There's lots of different words for this. Function, I think, will be the word that we use continuously. But we can think of this as a command. I command you to draw a line. Arguments are the parameters that define how we're going to execute that command. Right? If I'm trying to program you, I can say walk, or I can say walk fast, or I can say walk to this location, fast, or this location. Those are arguments to the command, the function walk. So everything we write, and the first ones we're going to learn are like rectangle, ellipse. We just did line already, and point.
Right.
So this I think is a nice, easy place for us to start. How do we define a rectangle? How do we define an ellipse?
So the available options, for at least right now, I'm certain there's more. Other draw commands. I don't know if that's how you spell it, of whatever the command is specifically. Line and point. Okay.
How do we define a line? How do we define a point? What are the arguments for each one of those? We can then draw rectangles, ellipses, lines, points. So what I would suggest to you, here's your exercise for the end of this video. What you should do is come up with some design that you would just draw with pencil and paper. If you've got graph paper, fantastic. Draw that design, make it simple. Only use rectangles, circle, ellipses, circles, lines, and points. And then try to guess what would the instructions look like with this kind of syntax. What arguments make sense for drawing a rectangle? Hint. The location, width, and height. What arguments make sense for an ellipse, for a line, for a point? Try to come up with something, and in the next video, we're going to start seeing the answers to some of these questions. We're going to start putting this code into processing, executing it, and seeing our first programs run. I don't know. I forgot to set a timer, so I don't know how long this was, but I was hoping it was just about 5 or 6 minutes, and if I look at it, it's like 20 minutes long or something.
Okay, that's something that I haven't done in a while, is actually going through and doing an actual exercise. I know, quite embarrassing. Thank you, public education. I've just probably been out of practice for such a long time. Okay, so, yeah, let's do it this way. I'm going to grab this, I'm going to grab another paint, simple as it is, bring it over here, modify. We're going to go to desktop. We're just going to temp. Yes. Okay. So, the instructions were specifically to create my own picture, drawing or something, and then we'll define how to draw it in processing very simply. So what I'm going to do is a horse. I know, a pony. Bam, look at this beautiful little creature. Okay, then we're going to do a little, that's weird. Looks like a Loch Ness monster or something. Probably like a triangle here, smaller one. Now it's getting complicated. And then little smiley face, 2 eyes. Well, I'll go with 1 eye. I know, this looks beautiful. It's like a little piggy. I don't know what this is anymore. I tried. The heck am I drawing? Oh, it's delightful. Okay. You know what if I drew a little piggy? What if I got rid of the neck? So I grabbed this, bring it over here, grabbed that, delete it, and just, oh. Transparent section. Okay, I know what I need to do. Get rid of this entire thing. This abomination. So, making it there. Nope. Select. Bam. I don't know what this is. You know, I'm gonna build a snowman. F it. Whatever. Circle. 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 And we gotta give this guy a top hat. Okay. This and that. Perfect. Gotta give it a 2 eyes. Weird looking eyes. Buttons. And then we gotta give this guy some arms. And then one coming from each of his. He has to have 3. For whatever reason. Different shapes, because that's how a twig does it. Looks, I guess. Delete. Okay. This guy's gonna get a nothing. Nothing else. Nothing else shall he have. Oh, that's smart. Okay. Nah. There you go. Bam. Now we'll go to the next video.
Hi, you came back. That's very kind of you. So we're ready now to take a look at processing itself and see if we can take some of this knowledge and apply it in processing itself. Write some code, draw some pictures to the screen. So what is processing? Where do we get it? How does it work? This is processing knowledge of a whole set of actions. You can type your code and execute your code, which is one of the wonderful things about processing. To the screen. But certainly, like, I'm like, this is the environment that you're going to type in. Hello, I love processing. Like, this could theoretically be our processing program. If we ran it, we're going to get some sort of errors. Like, I have no idea what that means. But it's an environment. This is the place where you can type your code and execute your code, which is one of the wonderful things about processing, because you don't have to figure out which text editor should I use and how do I compile them and where do I go view it and where do I debug it. Everything is here in processing itself. The other thing is really it's a community. So if we go back to this website, there are examples, there's a forum, there's it's open source, there is a rich community of people with lots of other sites that I can link to of using processing, sharing code, teaching with processing, making projects with processing. So in addition to just being software, there's also this vibrant community which will hopefully help you feel happier and more comfortable kind of diving into this new world of programming for the first time.
Welcome to
Okay, so once you've downloaded processing, you've run it, you've got this window. So a couple things I should point out, there is here, right? This is kind of the, I don't know what to call this, a toolbar, a little set of buttons. There's a bunch of things you can do. This is the one that I think is the most important. This triangle is the run button. It looks kind of like the play button on some media device, like I don't know, a VCR, an Apple TV. I don't think an Apple TV or a Roku box has play buttons. But anyway, the point is, this is your run button. But it does not really play. What run means is compile your code, and execute it. So it's going to run through your code, compile it into binary, execute, and run the program, which is why when we ran this one, we got this error. It said unexpected token hello. Now, one of the things I like about processing is it sometimes gives you a nice friendly error message, and sometimes it doesn't. But we can just, I don't mean to talk about this now, but whenever you have a mistake in your syntax, you're going to get an error. And that error will hopefully lead you to how to fix that, your syntax. But here we're saying it says unexpected token hello, because hello is not token meaning a sort of sequence of characters in between spaces and punctuation, a word, so to speak. It's unexpected because it doesn't know what hello means. Perhaps it would know what line means. So for example, if instead of writing that, I wrote line, and what did we say, 100, 50, 600, 250, and I put a semicolon, and I ran this program, we would see, I'm not over here. Hi. I apologize. This is I can't go back and fix it. It's just gonna have to someday I'll fix this video. I'll have a way to drop it to the beginning, or I'll probably need to re-record all of these because I'm just this is like a rehearsal really for that video that I imagine will be so perfect. But you can see I was able to run this program and there was no error. So this is fine syntax.
I'm trying to move that. I did the exact same thing. There we go. It's like I can only move it on the very edge.
It's the syntax we learned how to draw a line from point x from the first xy to the second xy. Now, the window we got here doesn't actually have the line, and it's also very small. Didn't we say that our window should be 640 by 360? Well, one of the things that we had to learn is actually how to set the size of the window. We can see that by default.
Because if I'm grabbing it up here, I can't. That's what I get freaking frustrated with. It's like, come on, what's going on? If I just grab it at the very top, then I can move it. Okay, apparently I can't. Run it again. This is lame.
If you don't specify a size, there it is. There's that program. Look at this.
Gotcha. Size 220, 720. That's not right at all. Why is the line that's not right at all. Why? Oh, 630. That can't be right. How did I come to that conclusion? I need to go back to my paint. No, that's really freaking dumb. Look at what I did. I think you already caught this. Okay. I need some more water. I'll be right back. So apparently I was wrong somewhere down the line of 137 being the X and then 630 being the Y. That's wrong. 630 is not where that number should be. The 630 at the bottom is. I wrote notes earlier, but I erased them. I can probably... oh. Okay, I know, it was with my notes. I didn't replace the Y. So when I was copying it over, it's like, okay, here's what the numbers are. Okay, now I know where we are. Now I know who I am. So if we're going to go with 8, that was the number. 1, 2, 3, 4-ish. So 5/8. 5 divided by 8 times 720 is 450, not the same number. So I'm going to write 450 again here in my notes. My freaking goodness. Stop it, computer. I want to punch something so freaking hard. Okay, so 137, 450. So I'm going to grab this. Actually, I might as well just delete the whole thing. Freaking frustrating. Okay. 450. Drag and drop. There we go. Can bring that back over. And now I'll do this again with 450 is the number. Run. Look at that. It's not exactly what I thought it was. It's not the exact same, but hey, look at that. Yeah, I'll take it. Okay, this needs to stop. It's too big. So yeah, it needs to be smaller, so I'll just have everything. Half it. Yeah. Yeah, I'll do that. So 1920, 720. I want to make